Okay. You have the nonlinear equations fx equal to exponent x minus sin x. Break it into two functions and sketch these two functions on the same plot. Locate a and b such that magnitude b minus a equal to 1. Then show there is a root in the interval by using intermediate value theorem. Of course, if you use your scientific calculator, you can actually directly obtain this graph and know the interval. But this question, they want you to break that nonlinear equation into two functions. Okay, then let's say you can break it. You can break maybe the y, because fx is equal to y, so the y equal to exponent x. When you break this one, you can break another one, y2 equal to sin x. So when you equal y and this y here, you have exponent x equal to sin x, or exponent when you equal these two, so you have exponent x equal to sin
Doktor,
x.
sorry, Zara nak masuk.
Please be punctual, otherwise I because I turn on the recording video, I cannot see, sir. No, nobody. So you have exponent x minus sin x equal to 0. So this part is what's your fx. The, the fx equal to exponent x minus sin x. And you can use your scientific calculator, or you can use Excel. If you want to perform it in Excel also can. But if you prefer manual, you can also use your calculator, to get the question one, two graph. So you have to plot y equal to exponent x, y equal to sin x on the same plot. Okay. So you can key in exponent x. Then the second function is sin x. Starting value. You just roughly put default is actually 1 to 5, and the ending is step is actually default is 1. This one I don't know why he saved the previous value there. Let's say I put from -5 to cos you know the trigonometry and the exponent x, you have a negative side, positive side. So I try just to put -5 to +5. And step sign is 1. So and then you can get the graph by scanning the QR code. So you see the graph here. Enter just now. So you break it into y equal to exponent x, y equal to sin x, and we plot it using the from the calculator. So from the calculator, you see the intersection will represent the root of these two nonlinear functions. The blue one is actually your y equal cos x. The red color, this is y equal to exponent x. The intersection of these two graphs will represent your the nonlinear function fx equal to exponent x, sorry, this is sin exponent x minus sin x. So you see is actually in between -4 to -2. Okay, let's say we put it negative, assume it is -3. Hence, okay, the question want you to use intermediate value theorem to prove, okay, there is a root in the interval, okay, the interval that you choose. Let's say we choose -4 to -3, then you have to prove it using intermediate value theorem as required by the question. Okay, where your fx is here, exponent x minus sin x, then you calculate f -4, okay, you calculate f -3. Prove that f, okay, f -4 multiply f, and the product of f -4 and f -3, you will get, okay, negative value. So I can see. We go back to the, okay, normal, okay, menu. Okay, input the functions back. Put your function exponent x, okay, minus sin, calculate for x is -4. So you have, okay, negative 0.7385. Okay, and then calculate again for x is -3. So calculate now x is -3. So you get positive 0.1909. Okay, and then, okay, you must put out, okay, you show, okay, one is negative, one is positive, so the product is negative, and you have to, okay, you have to show this one. Okay, it's either you pick -4, -3, and satisfy the interval that you choose, the magnitude is 1 unit. Maybe you choose -3 to -2, okay, up to you. As long as, okay, you satisfy that criteria, magnitude b minus a equal to 1, and then you have to come up with the conclusion. Since f -4 multiply f -3, you have negative, okay, then according to intermediate value theorem, okay, there is at least one root, okay, at least one root in the interval -4 to -3, at least one root, okay, in the interval -4 to -3. So we want this statement, okay, okay, prove it 1, 2, 3, and sketch the graph here. So you want to see two plot, okay, two curve on the same plot, and then choose, okay, the interval, calculate, okay, the a fb, prove that your, okay, fa fb negative when there is a root in the interval by, okay, by using intermediate value theorem. Okay, this one complete it mean by using intermediate value theorem. Intermediate value theorem.